Hello everyone, this is Dr. Mehler. Thanks for joining us for the overview of the Chapter 17 STEM Challenge. We're going to be looking at the nervous system this week. Remember, these are intended not as a lecture of everything, but kind of a focus talk about what things you should look for and what things we'll ask questions on. I hope you're staying safe and I hope these are helping. So let's move on to the first one here. And let's see, there we go. So you're going to be looking at the nervous system and the endocrine system. So please read all of 17.1 and 17.2. Take a look at this. This is a stylized version of a neuron. A neuron is another name for a nerve cell. And this nerve cell, if we take a look at it, right here is the nucleus. These are called the dendrites at the end over here. And this is referred to, if we're following the red part through here, this is the axon, which leads to the terminal, the end of the cell. And what's interesting about this is I'd like you to take a look at these blue sheaths. They're called Schwann cells that are around there. And one of the things you want to keep in mind is our nervous system acts and sends messages with real electricity, regular electricity. However, not in the amount that you're used to. For example, a AA battery. A AA battery is about 1.5 volts. If we were to take 1 volt and divide it by 1,000 parts, that would be a millivolt. That's the level at which your body sends signals with electricity. So let's read over what nerve cells are, what neurons, the cell body, the dendrites, the axon. We just did that. There are several types of neuron. There are sensory neurons, which take impulses from the tissue and the organs to the spinal cord and the brain. Then there are the motor neurons, which carry it the opposite way. And take a look at what interneurons are. This is a really nice video on what a neuron is. This is a young neurobiologist. Her name is Ali Axon. I think she does a really nice job. You're going to see a number of these in this chapter. You might want to watch this a couple times. In a couple of these, she goes in much more detail than I'll ask in the quiz, but they're still very much worth watching. Ali Axon, excuse me, we'll see her in a couple different ones. They'll talk about nerve impulses, and they'll also talk about resting and action potential. Resting potential is when, let's just say your arm, we'll use your arm is just sitting there doing nothing, and the electricity is flowing through, but there's no impulse going through. Here is a look at what causes, what allows that impulse to go through, called the action impulse. It's the sodium-potassium pump. There's a really good animation on that. I won't ask super specific questions on this, but I do want you to know that it's the sodium-potassium pump that allows the impulse to go through. The action potential is the impulse, okay? And you should read about what causes that. Here is Ali Axon, who is talking about what resting potential is. Take a look at that and make sure you read that. This is a stylized version. If we take a look here, here is the impulse of electricity that carries down the signal. And what happens is, for a short period of time, normally the axon is slightly positive outside the cell, slightly negative inside the cell. But when that impulse goes by, the polarity switches, the charges switch, so it becomes slightly negative on the outside, slightly positive on the inside. And that's because of a flow of ions in and out. So take a look at that. Here's the other one on what is a resting impulse. All of these are coming from Ali Axon. Really well done. This is a diagram from your textbook which shows you the brain, the central nervous system, which is the spinal cord and brain, and then finally just the spinal cord itself. The central nervous system is the brain and the spinal cord together. In this diagram, we see these blue, from the central nervous system, we see these blue lines coming out. Those are all individual nerves. And the sciatica, a lot of times you'll hear people talk about, oh, I'm having problems with my sciatica. This is the sciatic nerve, which is a big nerve which runs from the base of the central nervous system down into your leg and runs for a very, very long time, one of the longest nerves. Parts of the brain, there's the cerebrum, the brainstem, the cerebellum. Not this diagram, but this diagram I'd like you to know. This will be on the quiz. So these are the parts of the brain and what they are responsible for. So the frontal lobe is responsible for reasoning or thinking. Down, that's up here. Down below here, the temporal lobe is for hearing, occipital lobe for sight, and then the parietal is for touch. So I want you to know those sections of the brain. Another short video on Ali Axon on neurotransmissions, and she talks about parts of the brain. The somatic nervous system, which controls the voluntary activities, that's when you signal your brain, okay, I want to move my arm or I want to move my back. You're signaling that. But then there's the autonomic nervous system. Make sure you know the difference between those two. This is a very good short. It's a little dated, this particular animation, but it shows you how the light that we see on the outside is turned into an image on the back of our eye. So here's the image coming in. It goes through a lens. It makes it smaller and it flips it upside down on the back of the retina here. But right here, everyone, the image is now turned into electricity. That electricity flows up into the brain, into the occipital lobe. So watch this animation as well. Here's a close-up shot, cross-section of our eye, and that will help you understand the animation in the previous. Sound waves, so light waves come in from the world and we switch them into electricity. Well, sound waves come in through our ear, and right here is the eardrum or the tympanic membrane. Right here, those sound waves are converted through this series of steps into electricity, and then boom, out the auditory nerve to our brain. So this is how the human body picks up energy from around it. In the case of eyes, light. In the case of hearing, sound waves, and turns them into electrical signals so we can sense the world around us. Here's a animation from Fun Science Demos that Jared and I did a number of years ago. It's one of our more popular ones, and it's how your earwave works. This part right here is the inside of the ear. Over here is the outside, and this is your eardrum. Take a look at this one. This is a short one. It's only a little bit more than a minute, but I think you'll get a kick out of it, and you'll learn how the eardrum works. Right down here, just a reminder from your textbook what the autonomic nervous system and the somatic nervous system is. Read about drugs in the nervous system and examples of psychoactive drugs, coffee, tea, cola, coffee ice cream, hot cocoa. Disorders of the nervous system. Make sure you read through this and be generally familiar with what causes those disorders. Here we have Ali Axon talking about what an action potential is. And this is another animation where it talks about how the action potential works. That's how the pump works. I'd like you to watch this, but I'm not going to ask you questions on this in the quiz. Now, the endocrine system is another way. So the nervous system is a way of signaling all the muscles in our body to move or not move. Or the endocrine system, 17.2, are the glands and their effect on different organs. So this is another way that we can signal in our body. Electricity is the one way with millivolts, and the endocrine system is another way, but we use chemicals called hormones to signal how organs should work. So here are the major organs: pineal, hypothalamus, pituitary, thyroid, thymus, pancreas, adrenal, and ovary and testes, the sex hormones. Right here, how do your hormones work? This is very well done. Short animation from Ted Ed. Take a look at this one. I'm going to try something here at the end. I'm going to see if we start this, if this will pick up. No, I don't think it's going to work. I'm trying to get the sound from the computer to record. I don't think it does. I'll check it out. But anyway, watch this animation. I'm going to go back to this. Here's a list of the hormone itself, which gland is putting that out, and what it does. Go over that. This will talk about a little bit how hormones work. This is, you'll like this. This is a great demonstration on a person who started a company that makes devices that you can allow to hear the action impulses running up and down nerves. He does this with a cockroach. He's not being mean when he takes the leg of that cockroach off, because cockroaches, believe it or not, can regrow their legs and it's not painful. And this one, take my word for it, you're going to love this demonstration. This is when somebody else's brain, the young woman there on the left, is going to control a young man, a volunteer comes up with her brain. She's going to control his arm. Watch this, really well done. There's also a playlist. You don't have to watch these. There's a playlist, TED Ed lessons about the brain, overcoming depression. We talk a little bit about that. Okay, so I'm just flicking back here. Remember, this particular one you'll really like. Please watch this one. I hope all of you are staying safe. Know that we will get through this, but this is going to take a little bit of time. I think that the surge in the Philadelphia area is still coming in the next couple of weeks. I hope we are prepared. So happy that Temple is doing a big part in making bed space available and retrofitting the Leocore Center. If you have any questions, you can always email me. Good luck. There will be a quiz on Friday, the way we have the last couple of weeks. And remember, we are now up to Chapter 8 of Ed Young's I Contain Multitudes, and that will be due on Saturday. Seems hard to believe, but we're in the home stretch here, Chapters 8, 9, and 10 of Ed Young. Stay safe, everyone.